Hello and welcome to another video. In this video we're going to be continuing on the 2000 ELO Plus, and the next one's going to be this one. Looks like it goes at Q3. So let's actually make a counter, or a timer. So in this one, you're given an array of integers, price, K baskets, K distinct candies. Tastiness of a candy is the smallest absolute difference between the prices. Okay, return the maximum tastiness. Choose a candy so the price is $13,521. Tastiness. Okay, so you take all the whatever you choose, K, and then the tastiness is the min of all the differences. And so the min of all differences, like whatever you pick, can just be sorted increasing. So you would just get like 8 here, and then 8 here, and then obviously anything else would be bigger. So yeah, okay. 8 is the minimum. K is 2, so you just pick these two, so difference is 2. K is 2, difference is 0. Okay. Okay, so immediately, like, because you can pick K, I'm thinking like DP. So let's take a look at the constraints. Price length, 10 to the 5th. So we need to keep track of like the index and how many we've chosen or something. Doesn't quite work. Don't think. So let's say we choose candies. Like, how would we, like, what would be the best way to choose? I feel like let's say we have sorted candies. I feel like we would always just do some kind of greedy thing where we always just like pick one. Like, I think it's always optimal to pick the first, and then after that you'd figure out like what else. Because if you think about it, like, why would you pick anything above the first? Like, anything above the first, like if I had to pick between the first and anything above the first, well, the first would give me a bigger difference with everything else. So if I pick this, then after that, then I want to pick something above, and then so on. I'm actually thinking, I think we can do binary search. So essentially we can say like, let's just try to achieve some maximum thing. So let's say we try to achieve like 8 here. And then the way we would pick is we would just pick candies that let us do that. So we pick candy number 1, and then we'd pick the next candy above 1 that gives us 8 or higher, which would be 13. And then the next one that gives us 8 or higher again, which would be 21. And so it's possible. But if we try like 9, then we would pick 1 again, then we pick 13, and then there's nothing here. Yeah, so I think it's literally just binary search on the maximum difference, and then whatever, or the minimum difference. Like, we're going to try to achieve some minimum difference, and if we can get that, we'll just keep growing that. Alright, so sort. So what are the constraints? I mean, we can just go with, like, the minimum will be 0, and the maximum will be, like, max prices or whatever, or price is -1. I guess let's go with that, so the min will be 0, the max will be. Okay. We'll make result equal to 0, I guess, and we'll try to maximize. Alright, so we'll make a helper, like def is possible. We'll take diff, and we're just gonna see if we can get that. So essentially we'll just keep track of like count equals 0, or maybe 1. Cur will be like prices, or price the first one, then we'll loop through the rest. So if price is I minus count is greater or equal to diff, then this is allowed. So we'll go, or actually not count, cur. Then we'll just say we can take that guy too. Oops. And this is going to be our cur. Alright, and then we can just return count greater or equal to k. So if we were able to get k numbers. Alright, and then the rest is just pretty simple. So just pivot this guy if is possible. Pivot, we'll set result equals to pivot, And we'll try bigger. Otherwise, we'll go smaller. And then we just return result here. And obviously, like, the biggest should always be possible. Like, yeah, so, let's see. I feel like that's just it, right? Price. Okay. Nice. Yeah, so for these, like, whenever you're trying to get a max or something, kind of counterintuitive, but binary search is going to be, like, correct a lot. It's either going to be, like, heap, binary search, or DP. So the go-to should probably be DP for these hard problems. Look at the constraints, see if you could fit it. Can't in this case. And then, yeah, just got to realize that, like, if I was to select items, I would just select them greedily and I'd try to have a min diff. It's curious what the solutions are. Binary search sorting, binary search. Binary search, binary search. Did he sort? Sort the array, oven, binary search, long Okay, yeah, so pretty straightforward. Cool. So yeah, this will just be n log n. Or actually, so we're sorting prices, and then so it'll be more like n log n for the sort, which is, and then the other one will be n log, like, max or something. Something like that. Space 01. Alright, pretty good, 5 minutes. Yeah, I feel like with these, I either do it in 5 minutes or it takes longer. But definitely pretty happy that I can do it a lot of these 2000 in 5 minutes. Definitely once we get to the, like, the tough Q4s, it's probably going to be like an hour or two, so that'll be interesting. See how that goes. Alright, but yeah, call it there, and see you guys in the next one. Thanks for watching.